Hi everyone. So my name is Michael. I'm a search specialist with MongoDB. I'm quite a fresh joiner. I joined MongoDB last year, but most of my background has been in search for the last 15 years, give or take. So that's a topic I'm very passionate about. And today we're going to talk about search experiences and how you build that in MongoDB Atlas with Atlas Search. So the talk is aimed at people who are just starting out with search, or maybe are quite familiar with Mongo but haven't dealt with search before, and just to help you get started more easily and maybe spare you some confusion on how to use specific things. So first of all, rich search experiences. What are we talking about? 10 years ago, maybe 15 years ago, all we knew was the couple of big search engines. We had the Googles, the Yahoos, stuff like that. But nowadays, search is quite omnipresent. Every sort of tool, app, website, I dare you to try and find a reasonably complicated app that doesn't come with a search bar. So as the developers, we're kind of faced with the task of building these features, and sometimes it can get quite complicated. So welcome to the search bar and beyond. I'm going to take you through an example of, a couple of examples really, how to build a feature-complete search experience. First of all, are there any musicians in the room? No? Well, you might be familiar with this website then, especially as a European. I know, the English class, I'm probably go to Andertons or something. I'm German, so I go to Thomann. So I'm going to take you through the journey of me trying to find a guitar, because that's what I do when I get stuck and can't get motivated about getting back to practice. That's what you do. You buy another guitar, and maybe that gives you a boost of being willing to deal with it for a couple of months till eventually, you're getting too lazy again. So let's look at a case study. Now, disclaimer, they're not a MongoDB customer. It's just a website that I use a lot. And I want to talk you through the typical features that you see. So first off, most search engines you're using these days will start off with autocomplete, right? You start typing, and then it's going to bring back some suggestions. Different types. Some just suggest you products right away. Some complete terms. Some complete filters. So if you go to Andertons, you're going to have things like top searches, right? Now, after you run your initial search, what's going to happen? You have your search bar, you have the search results that have been returned. And on the left side, you typically find on pretty much any search engine, especially any sort of e-commerce website, you're going to find a bunch of filters that help you narrow down the scope. Because you don't want to page through 50 pages. You also don't want to put 5 different category terms. Yeah, I don't want to go to Thomann and say I had Solar 7th string with maple body and this finish and this bridge. You typically start off with a couple of keywords and then just expect filters to be there to help the user narrow down the search quickly, so he doesn't have to page through 100 pages of search results, right? And there's different types, right? There's, we call them facets, so there's text filters, there's range filters, there's numeric stuff, there's histograms, so all different kinds. And then, of course, sorting. So if I want to explore, 8-string instruments or something, I might want to sort by price and, try a cheap one before I try a big one. Or if I'm a Gibson fan, I sort in reverse and get the most expensive one. I don't know. So sorting, also to be expected, right? And then there's pagination. There's different types. So with some tools, you'll see the endless scrolling sort of thing. So if you go, especially on social media, you would have these endless scroll. Once you get down to the bottom of the page, it's going to present the next batch of results. Or you have discrete pagination where you can specify a number, say go to page 5. Or in case of Thomann, they kind of couldn't decide, so they have both. It's a show more, but you also pick a page to jump to, right? So let's walk through a couple of these features and discuss how you would build these with Atlas Search. First, to recap, so Atlas Search introduces a new way of indexing. And MongoDB already counts with indexes, right? So why do we need 2 different sorts of indexes? What's the difference? First of all, both are there to improve your performance. Both support different types of queries. So there's range, there's exact filtering or querying. With text indexing, you also have fuzzy search, stuff like that. But there's more differences beyond that. So first of all, With search, you typically expect, and that's the main aspect of why you need specific indexing types for text, there's scoring. So you don't sort by like discrete criteria, like a price, not always. You also expect some sort of score that returns more relevant, more interesting result for the user, which is big differences compared to the classical indexing, where all you have is basically filters. They're both built into the query API, so you can use both from your query language. It's just an aggregation pipeline stage. The big difference with search, and that's very typical with search though, is you have to know ahead of time what kind of features you're trying to offer. You have to come up with an index configuration. So you have to take into consideration what features users are going to use and what you're going to need. And if you change any of that, it's going to take some time because you got to re-index, re-ingest, because in creating indexes it can be quite expensive. So we're going to focus on that aspect. Easy start, I'm going to go to the search bar first. I know, like typically we'll start with type ahead, but like start with simpler stuff. So I'm going to type in a bunch of keywords. I'm going to go search for guitars of this brand. You know what I do? I just plug that into a $search stage, which I can provide with just my keywords and point to a field. Let's say I'm searching for description. But actually, in reality, like oftentimes the fields we want to search are going to be multiple ones, like the title of a document, the description, maybe some tags. So you plug all of those into an array of fields or add multiple clauses. So now we covered that, right? But the next challenge you're going to face is, especially in text search, vocabulary plays a huge role. So most terms aren't like started, so people do use different words for the same thing. So for example, a whammy bar, that's like the little thing on your guitar that helps you like shift the pitch up and down. Like some call it a vibrato arm, some call it a tremolo bar. I'm not gonna start semantic arguments what the correct term is, but I'm gonna call it a whammy bar. So how do you treat that? Like MongoDB actually has a very, very elegant mechanism where you can keep all these synonyms in a MongoDB collection, which make it quite easy to, for example, ingest data, build integrations with other systems, make things like making use of chain streams, for example, to trigger stuff. So I get a lot of this integration. So what you're going to need is a collection with these terms and a configuration in your index, giving basically your synonyms dictionary name. In this case, I just named product synonyms. And specify your search stage to make use of that. So once we do that, we're going to hit search result for both whammy, tremolo, vibrato, whatever is specified, right? Kind of easy, convenient way. Now, the next thing is, though, I don't always want, there's different types of search engines, right? With some search engines, we want to present the users with the best sort of information. That's going to be the type with, for example, knowledge bases, where I kind of want to present the most relevant, most positive result. In e-commerce, typically, like if you ask anyone, the goal is not to present the user with what he's looking for. The goal is to present him with something he's going to buy, right? But that can also translate to a lot of other areas too. For example, even in knowledge bases and classic knowledge retrieval, I would look into, for example, the user's context and decide to present someone from sales with a different ranking and result set than someone from engineering, right? So even in different areas of search, you would typically have lots of use cases for boosting specific types of results based on the user context, on his background, which part of the organization he belongs to. Right, so how do we do that? Actually, there's separation in there's a compile clause in search that's gonna provide different properties. There's must, there's should not. So the big differences, the big ones are filter, which is not gonna influence your scores. And then there's must. All the clauses, it's a logical and. All the criteria in the must stage will be met with your results. And it contributes to score. And then there's optional should clauses that you can use to basically boost the scores of specific documents. So what we're going to do here is we're going to have a bunch of tags. It can be categories. It can be tags of documents. It can be specific features based on the user's history with the company or something. And we're going to give it a boost to its score. And by the way, all of these queries, I have a GitHub gist. There's going to be a QR code at the end. There's Atlas Search Playground, so you don't have to memorize any of that. Just me talking you through what I'm doing here. And I have a nice write-up on there, so you can just follow the QR code, look at the queries, click on the links, see them in action, and play around with them, right? So with boosting some, for example, I want to boost something that is on sale, right? Easy. So the next step, after I've returned my initial batch of search results, is going to provide users with meaningful options for filtering, narrow down his search results, because I don't want my user to click through 40 pages of results to get there. I want him to navigate there and get there as fast as possible, and that's what we use Facets for. So on the left side, with most websites and many tools, or maybe sometimes on the top, if you're on a mobile phone, you're going to have an array of filter options that will help your user get to this desired sort of product, result, document a bit faster. It might be a data source, it might be a product category, it might be a specific feature. Right? How do we fetch these values and the counts? Right? So to do that, let's say I want to offer a filtering option for the fretboard. In case you're wondering what the fretboard is, let's see. The fretboard, sometimes called the fingerboard, I'm not going to start semantic discussions. So it's the part of the guitar where the frets are inset, or where your fingers touch, so both options are kind of valid, right? So what I'm going to do, I'm going to use a different pipeline syntax here. So I'm going to take my compound clause, so my filtering criteria, and I'm going to move that into a facet and an operator. So the operator is what defines my filtering criteria. And the facets is what's going to define which filters I want to present, basically what I want to do my counts on. Right? So we're going to add a facet of type string and point to the path where I'm storing it. So in this case, it's like a nested document called properties, and then there's one called fretboard. So in this case, I kind of decided on the nomenclature here. One neat trick that you can do if you want to return both the faceting results as well as the document results in one request is you can add the facet pipeline stage afterwards. If you're familiar with it, it basically takes your previous results and processes and runs like a process in multiple parallel ways. So we're going to take it and nest our search results into a project stage where I can collect all my search results, and the second one is going to be just limited to one. I'm going to just replace the document with a search meta. You can also, and most of the time I would choose to run my facets with the search meta stage, which only return the search metadata, only the facet, and the search in parallel for better performance. But there's good reasons why you want to do it in one request. For example, if you have rapidly changing data, so like a second level or something. Every second the data is going to change. It's a small data set, and the fluctuations are quite high, and I want it to be consistent between my search result and the facet counts. That might be a good use case where you can want to do both to make sure they're really in sync and haven't changed between the two requests, because one might arrive a bit faster than the other one. But it also helps us just see all the results in one request for this particular scenario. So that's going to return an object with all my results, as you can see, a bunch of them, and a metadata array. So my search results with my projection stage, I'm just going to return the description, the name, as well as the facets, which are going to have a series of buckets, and each bucket is basically the value of the given field and a count. So this is what I'm going to present to the users on my website, right, on my app. So ebony, amaranth, maple, a bunch of options, different types of wood. Judging by my outfit, you can guess what my favorite color is going to be. No, I'm actually not gonna go with ebony because, if I go on stage, with black outfit, black guitar, black everything, I'm just gonna disappear and be a floating head with a bunch of guitar strings. So I'm gonna go with maple, nice contrast. So how do we apply this choice, right? What we're gonna do is we're gonna take the value and just plug it back into the filter stage, just as a value to the field. So this way, I'm taking the choice. So in this case, a black guitar with a maple fretboard. I'm added the maple to the filters. So over time, we can accumulate this filter and enrich it. So that's going to do the pre-filtering. The filter is not going to influence the score, nothing. And make sure that the next round of results I'm going to present is going to be narrowed down to only things that match my filter. And we do that iteratively, so offering the user more choices. For example, I'm going to add a body selection for the type of wood I want in my body, and the string type and number of strings. All of these choices I want to give to the users, present different facets for them, keep adding the user selection to the filters when you present the new round of results. So it's going to update the facet counts, it's going to update search results, and you work your way till you narrow down the scope, ideally to a point where the user is going to see what he's looking for on the first page of results. That's always what we're aiming at. So if you look into any sort of scoring mechanisms, how we measure search result quality. It's mostly how far from like the top 3 or something is our search result. So that's always what we're optimizing for. I want to see my search result on the very first page on like in the top 3. Because users, like how often have you gone to Google and navigated beyond like the first page of results? It's pretty rare unless there's like, you're looking for this one error message and there's only like 2 pages or something. Right, so you keep repeating that and eventually you arrive at like a quite small subset of documents and hopefully the right things are going to be there. So to recap, facets and filtering, you use a facet operator to generate unique values for the given scope. So with applied, like with all the text clauses applied, with all the previous filters applied, and the counts to give the user a hint how much results are going to be there, even before he clicks on it. And then you use the compound filter clause and keep adding to that in order to filter the results and present kind of the next batch. Okay, now we narrowed down our result scope, but you might want to go in and sort by something. So the default for every search engine, and that's the case with Atlas Search as well, is search things by relevance, meaning how much of an overlap do your search keywords, your terms have with the documents, normalized by document length and all of this stuff. But sometimes users want to have choice. Maybe they want the most expensive or the least expensive guitars. Maybe they want new arrivals, stuff like that. Quite easy. What you're going to do is, ahead of time, consider what choices you want to offer. Make sure they are being added to the indexing configuration. So if it's a numeric, you have to index as a numeric. If it's a string, you want to make sure it's indexed as well. And then you just add a sort property with a 1 or -1, what works pretty much identical to the default like $search stage. Easy. So now we sorted the sort out, and we get to the next stage. So let's say there's still like 500 pages of results left, because you'll realize there's going to be like a whole lot of brands of guitar instruments out there. So how do we build this pagination? And we have 2 different mechanisms, right? There's like the load more, so the sequential navigation with the offset, and then there's the pagination, which is kind of non-sequential. So maybe I want to jump straight into like the 7th page or something. First of all, the result comes back. So the first results, page of results, I'm obviously going to add some limit, with a quote arbitrary 25 results per page or something, maybe a bit less on a mobile device. So I have my first page of results. Let's say it's 1 to 100 to make the math a bit easier. If you use a facet stage, by the way, what's going to happen is like the facet stage, the $facet, is going to consume all results from the previous stage and wrap that into an object. So I don't think the server is going to explode, but it's definitely going to error out if you have too many documents. So what we want to do, especially if we're using the facet stage, so we're not consuming a cursor. The cursor is going to be one document with all our values, and we probably don't want to blow that up. We're going to add a $limit stage to make sure we limit the result set before we pass it to $facet. So now, with that sorted, you need to know how many documents you've got. At least if you want to offer any sort of like non-sequential navigation where you want to jump ahead, you need to know what the count is. And the default is to present an approximate count, unless you add a property and say, like, I want the total count. That obviously introduces a little bit of overhead, because the search engine has to now go and inspect like all the indexes and do a proper count, as compared to just knowing, hey, there's like at least like 1 page of results. So we add that, and that's going to give us a count that we can use to calculate the number of pages and offer some choices. And we want to add, for sequential navigation, a meta, which is called a search sequence token. That's going to be added to every single document, and that's going to act as an offset, or let's say a checkpoint, so we can do sequential navigation. So let's say we calculated based on our result count that we're going to have like a lot of pages, like 31 in this case, right? How do we go from the first page to the second page? First of all, and that's something to pay attention to unless you want to have unexpected results. When you do this sequential navigation with the sequence token, it's vital to have like a deterministic result order. And that's not always going to be the case with search scores, because you might have multiple documents with an identical score if they have like the same name properties, the same tags, something. If you have multiple nodes for load balancing, the default for search nodes is going to be 2 nodes. The insert order might be slightly different. So the results might come back differently if the scores are absolutely identical. So always try and add some sort of tiebreaker. It can be a document ID, it can be like a SKU, something. Make sure you add something beyond the search score. And that's going to give you a deterministic sort order and allow you to paginate easily. So what you're going to do, you're going to grab the last sequence token, and you're going to plug that into a search after property. So that would make all search results that will come back in the next round trip like an offset, right? So if I want to get results from like the 101st to 200, that's going to be like search after of the last item on the first page, right? Easy. Now, what do I do if I don't have a sequence token, right? Let's say I want to jump to the 4th, to the 7th, to the 8th page, right? It doesn't work this way. So what I'm going to do, and I'm still using the search after token, we're going to discuss that in a moment, I can add a very familiar stage from the aggregation pipeline, the skip one. So if we recall, we using the search after from like the last result on the first page or something, and then we skip 600. So easy math. I'm starting with the 101st, I'm skipping 600, so 701 is going to be the first search result, and then like the limit clause. So I'm returning results 701 to 800 on the next page, right? Now, 2 ways of going about that, right? So I could use a sequence token, I can use a skip. So with the sequence token, I obviously have some offset coming from search index, and then I'm skipping a bunch. I could also just use skip. Now, why don't we do that? Let's discuss, right? Let's say I need to jump like way ahead, right? If I use search after, I can skip a bunch of results straight from the search index side of things, right? Right in the first stage, I'm always gonna start returning results from like the right checkpoint, right? No skip needed. So if I've jumped to the 7th page previously, I should grab the sequence token and plug that back in for the next stage, the subsequent stage. Otherwise, what I have to do is return way more documents and start at a larger offset. So that's going to introduce a bit more latency because, as you might be aware, like the aggregation pipelines work sequentially, which will force the first stage to return way more result than it has to, right? So why don't we do that? Because we don't want to grab like 900 results to return 100 if I got any other choice, right? So instead, give it an offset, make sure you avoid skip. Don't try to skip ahead like tons of results, especially like the further you get in the pipeline, the more it has skipped, the longer it's going to take. And you don't want like the 12th page of search results or something to take like significantly longer than the first one, right? So try to combine both and basically use a combination of like the offsets whenever you have to navigate like non-sequentially, jump ahead, you skip, but once you get there, like for the subsequent pages, make sure you use the sequence token, right? So what do you do if you want to go to the previous page then? Kind of the same thing. You grab the sequence token of the first document, and you use the search before. So it does the same exact thing, exact in reverse, and that's one thing you might come across. It's in reverse because, again, like the search stage itself doesn't come with a limit. It doesn't know how large your page size is going to be. So what's the solution to that? It's going to start returning like your results in reverse from your last checkpoint. So pay attention to that. You can use, for example, like a limit clause and then like the array reverse, for example, operation to bring it back in order, or you do that client side. Not a big of a deal, but just be wary of this because you might be confused with like wrong looking pagination and wrong order of results if you're not keeping that in mind, right? So again, you don't have to use skip. You don't have to skip 700 documents to return the previous page. You can use search before and do it sequentially, which always will result in better performance. So to recap, use limit to fetch only the number of results you're going to show. to not introduce any latency, any overhead, memory, and so on, try to use the deterministic sort. So introduce a second criteria, like in SKU, something that is unique enough to act as a tiebreaker. Generate the search sequence token, so you can always paginate sequentially whenever possible, and combine both of those with skip and so on to paginate properly. Right, so now I can move from one page to another. What's next? So now we're going back to the very beginning. Like, how do I start every single search? I'm start searching with autocomplete, right? I want to present users with meaningful results or maybe ways of narrowing down the search scope even before they run the search, because the less interactions I need to have as a user, the better my experience is going to be, right? So how do we do these things? Let's look, for example, again at Anderton's website, right? The moment I start typing, it's going to present me with two different types of things. There's going to be my top searches, which might be based on my personal history, which might be, so some tools do that. They display like your last couple of queries, especially if you keep coming back to the same tool looking for the same things. So not so likely for websites, but maybe very highly likely for internal tools, like where I would want to go back and check every couple of days whether something changed, right, on a given like document or something. And then it will present me with actual documents or maybe categories and stuff like that. So how do I build that? So first of all, there's an autocomplete field type in Atlas Search. So you can configure your index to do autocomplete on specific fields. And there's an autocomplete stage. So that takes a prefix and we'll run a search using this prefix on the autocomplete field, returning a bunch of documents. So that's what most websites are going to do. So if I start typing, they're going to present me some results. Now, the interesting thing is, it's not just a result for documents, right? Because my main body of text or my main body of documents is going to be products, right? So where do these category suggestions come from? Where do the queries come from? Now, we recommend a pattern we call the entity collection. That's actually, if you just search for Atlas Search, building entities, you're going to find like 1 or 2 blog posts on that. So we have a nice write-up from my colleague Eric on this. So to give you like the quintessential like pattern here, what you're going to do is with search in general, you always want to keep track of your queries and try to use them to measure accuracy, to keep a history, to understand what your users are searching for, what they do on websites. How to use that? Keep them in MongoDB collection, right? So every time you have a search query, or maybe search query and then like an interaction with the result, so you can measure the click-through rate, keep track of your queries, keep track of like the counts and the values in a separate collection. Easy. So we're gonna pour that, in my case, in an entities collection. Maybe you want to have like a separate, let's say, queries collection with like TTL indexes, stuff like that. So the easy case, though, very basic, we're going to make an entities collection, and we want to keep track of like the most popular queries in there, right? So in this case, rather than running my autocomplete on my products, in parallel to that, so I'm also going to search on my products, but I'm also going to search my entities collection for anything matching that. So part of that is going to be, for example, popular queries data. So I can start matching on queries. So as you can see, I've added a filter, so I'm going to have more types in my collection. So I'm searching for queries, and I'm using autocomplete there, right? So you're going to end up with a bunch of results. And looking at that, so why do they look the way they look, right? So I have some more popular queries with a higher popularity, higher rating, higher score, however I want to keep track of that. Way down, so what do? First of all, we need to understand what the scoring looks like in the first place, right? So I add the meta search score that's going to return the scores likely. And I can see, some of the more popular queries have like a lower score because, for example, the queries are longer. My search keyword is quite short. So how to remedy that? I can, of course, use a static score and just take the field value, but I need to figure out a way to mix that. So what you would typically do is use the score clause with a boost on a path, which will take the value of a numeric field and use that as like a multiplicative factor. Now you can see how that can quickly escalate, like just a tiny bit. So if you multiply something with like 400 or something, it's obviously going to dominate your results, and you don't want to do that. So find ways to maybe normalize the fields a little bit to like a reasonable range. Right, so with that though, I can see how my more popular queries are going to be flushed to the top, offering more relevant things as compared to something that was searched maybe once. Right, so with that, that's what you would typically do with all the different clauses. For example, if you recall the page, we had type ahead suggestions for popular queries, but also like products, different manufacturers, different models, all that stuff. And it's basically a business decision or a marketing decision, a UX thing, what kind of like suggestions you want to prioritize. So you're going to go in and kind of mix different scores for different things. That's where the compound clause is kind of useful. So your filter is obviously going to be like anything that matches a prefix, but your compound clause is also going to look, in this case, for different types of completions and boost each type differently. So some of them might be like the popularity of query, but some might be just a static boost. So in this case, I'm saying like, look, if I have matches on the model or something, I'm going to boost it way more than something generic like maybe a manufacturer name, or maybe something even more generic like a category of results or something. Right? So mix and match to make sure you have the best user experience. That's quite easy. And at the end of the day, the syntax defining the query in JSON makes it very, very simple to make the query composable. So what I do is basically write your own little query builders that's going to enrich these clauses and have like a generic method to basically say, look, add boost clause on like type manufacturer, give it a boost of 10, and experiment a little bit with that. Right? Especially if you have like a public-facing thing, feel free to experiment. Route your 5% of your users, 1% of your users to like a different boosting mechanism, see what they interact with the most, and then iterate on that. Figure out what they're using. So make sure to always try and store as much information on what they're doing with the website as possible or your app, and try to understand how you can steer them towards best results. If you realize user searched for something and only clicked on a result from a certain page, well, there's some room for optimization, right? Now, what are you going to do if you want to search for something with fuzziness? Because users sometimes mistype. Some keys are quite close to another. Also, autocorrection on mobile devices will mess with your results and make like fender a bender and so forth. So how do you deal with that? Well, there's the fuzzy clause. The fuzzy clause will introduce, and you can parameterize it and say like the edit distance between 1 and 2. So that will allow the query to tolerate up to, I think, 2 characters added, removed, changed. And that's going to help you, for example, take bend or bender and match that to a fender because of like one changed character. Now, some room for caution because especially with short prefixes, you probably don't want to leave like the edit distance in 2 because that will match literally everything and anything. So vary that a little bit. Look at like how long the query is, and depending on that, maybe like add fuzziness at all. So I wouldn't add any fuzziness at like 3 characters or something. I would start at 4, and then as the query gets longer, expand it to 2. To make sure you don't get like super unexpected results, because keep in mind, edit also applies to the first character, for example. So the user might see something that starts with a different character, or is like very, very, very odd and unexpected. Right. So what about counts? Again, you can use search in your entities collection and store counts in there, so you can aggregate on your main collection. Just basically write a merge pipeline to run periodically and fetch counts of any given value. So update your entities collection. You can also use a computed pattern, basically have a change stream or look at a timestamp and then update it periodically to make sure you have counts to present. Or you can go the other way around. So you could also run for your main collection at least, for some of the facets. Sure, just run a facet search. So what you can do is basically narrow down your query using an autocomplete clause and then do faceting. So you can also use autocomplete with faceting, so you can get an approximate count. Now, where it can get a bit confusing is if you have multi-value fields, because facets apply on the documents themselves, so there's no guarantee, and you have to post-filter to make sure that if you have a field like tags, features, anything that's multi-value, that you're not going to return anything that is starting with the wrong prefix or something. So some room for caution. Works great for like single value fields. Might require some like post filtering, reordering, stuff like that if you want to present results for multi-value fields, right? So the nice thing about that is that you can apply your search context. So what do you do, for example, if you have a lot of different values? So let's say you have, I don't know, 800 different manufacturers at your shop, and the facet is like playing for usability purposes, probably like the top 5 or top 10 choices. How do you let the users know what kind of choices they have and let them search? Similar mechanism, you can introduce type ahead, so you can pre-filter on everything that's the current search context, and then add an autocomplete, and then only return facets or facet values for the given query. So this way you can also pre-filter the values of a given facet and introduce, for example, for each and every filter you're going to offer, each own little type ahead field. So if you have something like a manufacturer, a brand, a model, like anything really, offer them a nice type ahead functionality so they don't have to scroll through like 800 choices to find what they're looking for. So very, very easy to implement. Again, just filter by the current context, so the keywords, the categories, whatever the user applies, add an autocomplete filter post, and then do faceting on that. So you're now returning like only the results for a given facet, so to speak. It's quite fast. You can use a search meta stage, return quickly in single round trip, and have like a pre-filter for any valid value. Right? So there's many different types of autocompletion. You see that, especially in Google, sometimes Amazon, like shops typically offer many different types. Also more modern, like enterprise search engines, will offer you different types of information, right? So there's the completion of terms, there's completion of synonyms. Sometimes you're gonna return entities, so you can mix and match and really like return pretty much everything, anything, as long as it's like an index entities. So that's very easy to implement if you use the entities collection pattern. Just put everything you would want your users to search on this collection, and then you can return all these different types of suggestions, right? So there's queries, there's entities, sometimes it's like the next term. So that's a bit more tricky. So in this case, you have to build your own collection or keep the query history and see, can I match this prefix? And all of these you can build with the query structures I presented above. And get creative. If you look for in something like IMDb, for example, the type ahead is actually they don't really like try and even present you with a page of search results. They do everything in type ahead. So it's huge. It's a ginormous window for turning different types of completions. From like here's this movie to here's an embedded trailer of something. So you can get very creative. I think it's a huge value add to the UX, to just allow users to navigate there easily. So get creative. Try different types of suggestions, make them very rich. It's not too hard today to use like React Native, whatever, to build like composable components for your type ahead and return stuff beyond like here's the 10 bits of text that you might want to complete on, right? So to recap, there's many, many ways to set up autocomplete experiences. For the dropdown, keep your collection of popular queries, make it perhaps user-specific, so you can still use Boost and so on to make sure, for example, if someone from sales is doing autocomplete, or like a return customer where you have like a query history of, has some sort of setting, preferred categories, stuff like that. Try to build dynamic boosting to make sure you present more relevant results. Direct them as much as you can. Offer suggestions for categories and filters. Same thing, if you have your entities collections with all the different choices for a given facet, why not present him, like, look, if I start typing like solar, or if I start typing guitar, like present him with a category choice, like 7-string guitar, so he can click on it and enter into like a search with a pre-filter selected. That would help him navigate, right? And also make sure you use like autocorrect synonyms, some sort of typo tolerance to account for example, mobile devices correcting stuff or the users sometimes mistyping, right? Easy. So again, as mentioned, there's a QR code. Feel free to scan it. I'm going to leave it up here. That's going to lead you to like a GitHub gist with an exhaustive write-up of all the things I mentioned today. And under each query block, there's going to be a link to the Atlas Search Playground. If you're not familiar with it, it's like a very convenient way to experiment. So you can add some sample data. You can write down an index definition and run a bunch of queries. So that's very convenient to do experimentation, understand, how does a specific query work So there's going to be a bunch of links, so you can try all of these things very, very easily. I'm also going to be around, so if you want to talk about search, vector search, like whatever, I'm going to be on Expo most of the second half of the day, so feel free to come up, chat to me at the AI booth or something. I'm going to be there. Right.